Welcome to the DevOps Chronicles, Kubifying Java applications with Dekorate.io. A little bit about myself. I'm Anna. I am currently working as a developer advocate and also Java Champion alumni and certified architect. You can find me on Twitter at Ambra1508, where I post about things that I do, tutorials, and other content that could help you in your day-to-day life as developers, Java developers in special. And I'm passionate about solving scenarios that are a little bit more complex around Java and Kubernetes. Hence the topic of today that actually bridges both the Java world with the Kubernetes world. And throughout time, as developers, we kind of experience different types of headaches, sometimes when we're working on something very difficult to solve or to implement. But in particular, when working with Java and Kubernetes, the biggest headache is writing and maintaining YAML. And in order to address this challenge for us as Java developers, it would be great if we have a tool that could help us in dealing with YAML. And this is what Dekorate is about. So Dekorate is a set of tools that help you as a Java developer to deal with writing and maintaining YAML files, specifically containing Kubernetes resources. So what are the strengths of Dekorate? So Dekorate can help you generate Kubernetes manifests, and it works with all the Java build tools. So it works with Maven, Gradle, Bazel, SBT. You just need to add the Dekorate dependency to your own class path, and you will be able to work with it in no time. Now, it also allows you to customize the generated output, and it does that not by you going and writing in those YAML files the information, but by using properties or annotations in your Java code, which is much more friendlier than dealing with YAML. You still have to know a little bit about Kubernetes, but still, you don't have to interact with YAML as much as before. Thirdly, it integrates well with various frameworks. So it works very well with a lot of frameworks. And for some, it can even adjust the generated manifests according to the detected framework. So sometimes Dekorate can detect the framework and generate even better the output of resources without you necessarily needing to tailor that too much with your properties or your annotations. So how to use Dekorate? First of all, I assume that you would like to develop a Java application. Then you just add Dekorate as dependency via your favorite Java build tool. And then you can use just annotations and properties to customize the output in Kubernetes manifests. And last but not least, you deploy the application. Simple as that. Now let's jump into the demo context, because there are going to be kind of a lot of demos today. So the demo context, it has 3 applications, because I thought to demo Dekorate with different frameworks so that you can see that it works in different contexts. You're not bounded to a specific framework to use Dekorate. So I am using the same to-do app with different flavors in SpringBoot, Helidon, and Quarkus. Now for the SpringBoot and Helidon to-do app, I was able to use the Dekorate Docker build hook, which is another dependency that can help you to containerize your application if you already have a Docker file. After I'm using this, I'm able to build and push my container image to my registry. And afterwards, I can work with annotations and properties to generate Kubernetes manifests. Now, this is the case of these 2 frameworks. And then, using those Kubernetes manifests, I can just simply deploy to my desired Kubernetes cluster. Now, in case of Quarkus, Quarkus incorporates Dekorate inside it through its extensions. So, in case of Quarkus, the containerization goes with the Docker extension, and customization goes only with properties, no annotations. Thanks to properties, then you get more Kubernetes manifests, and you can deploy those in the cluster as well as before. So this is just a summary of what we're going to do next, so that you have a big picture of what's going to happen. Just to warm you up, this part will not be demoed, but just to know how it happened, the part with Dockerizing the apps. So what do you need in order to Dockerize an application with Dekorate build hook? First of all, develop an application and have a Docker file in project module root. You can also specify a path to your Docker file when you're using the Docker build hook. But if you just want to go the easy way, have that at the project module root, and it will work automatically. Then you just add the Docker annotations dependency in your Maven or your Gradle or whatever tool you're using to build your Java project. Thirdly, you can adjust the registry, the group, the image name, and the tag details to where you want to build and push your container image. And third, you just build and push your container image using Java commands, using, for example, Maven. And you can just use mvn clean package, specify 2 flags. You can do this also in properties or annotations, by the way. But if you just want to go with the packaging part, you just need to do decorate.build equals true, that will build your container image, and decorate.push, that will push your container image to your container image registry. Easy as that. Now let's get to the most interesting part, generating Kubernetes resources. Now this part is going to be demoed for all the 3 frameworks. The other ones, I will let you choose for which one you would like to see the demo. So the first part is using Dekorate to deploy the Helidon to-do to Kubernetes. Now this application of mine is actually taken from the Helidon examples, and it has 2 parts. So if I'm going to my own IDE, I have a backend and a front end for it. I will just go with using Dekorate for the front end in the demo, but you will find in the code repo that I use Dekorate for both parts, so it's not much difference. And in order to have these 2 projects communicate between each other and keep up with the 12 factors and externalize my configurations, I'm also using a config map as a way to communicate some URLs between the 2. So this means that I will need to customize a little bit my Kubernetes output. So let's start by just going to the front-end project and add Dekorate first. So just going here and make this bigger, and put the dependency. Hope the laptop is going to be fast. OK, io.dekorate, not Knative, but Kubernetes. And of course, I'm just going to keep the same version as the one above, which is 3.0.0. I think this is the latest one. And just get my Dekorate here. Now that I did this, I just need to go to my main application, for example, where I already have the Docker build. I don't want to push again and build and push again while doing this because it will take me a longer time. OK, let me make this bigger, minimize this. And now, hopefully, I can add my own annotation here with my own implication. So first of all, I need to annotate this with Kubernetes application. Come on. Just signal to the package that this will be generating Kubernetes manifests. Then I can specify ports for my container, for example. Then my container port by default will be 8080. But because I'm using a config map, I also need to mount that as a volume, which is a good practice when working with config maps. So I just need to give him a name and say config volume. I also need to put the same thing in here, in the volume name. I should give a path to my volume, like where do I find this information? It's going to be on /conf. And then I'm just going to map this as a config map value and give the name of my config map, which is a good thing to check right now. kubectl get config map. Get what's in my cluster. I hope the internet is working. I'm relying on it. OK. Good. It responded after some point. So the name is Hello Examples to do backend. OK, just get it here. And that's it. Now let's generate the Kubernetes manifest. So let's say mvn clean package -d skip tests, and just run this and see what's going to happen. So this should be like not taking a lot of time because I'm skipping a lot of information. Build was success. And the generated output is in /target classes meta-inf dekorate kubernetes.yaml. Let's see what got here. So what got here is about is the following. So there's a deployment with, of course, the environment of variables that I specified with my volume, which is a config map. Then there's also a service available And of course, maybe I can add a few more things to this one, because right now I cannot expose my application to the external world, and that would be great to have. So maybe I can do this, specify a service, and say service type, service.load balancer, and also ingress, and say at ingress, and use the expose true for it. Now let's build this again and have something much more thorough generated with this. Work very fast. Now also we have an ingress resource generated. The resource, everything is load balancer. So let's go and say kubectl apply, or go with kubectl apply on this one, -f, target, classes, meta-inf, decorate, kubernetes.yaml, and just deploy it, hoping that this one is going to go even faster. kubectl get pods. Okay, it's already running. kubectl get services, so I can get my endpoint. Okay. Front end is still pending. Just a moment. Probably it'll take a while to get an IP so that I can access my application. But it was easy like that to generate my resources, my YAML resources, just from the Java side, not anymore looking into the Kubernetes side of things. Let me go again, hoping that it's going to stabilize at some point. It takes a little while. Anyway, I hope that after I'm demoing this, I can show the URL. So what I did, just to summarize, I just added the Kubernetes annotations dependency. I used the annotations, in this case, to configure the generated Kubernetes resources, and I just deployed to Kubernetes. Now, you can deploy to Kubernetes using kubectl, or you can deploy to Kubernetes with the flag -ddecorate.deploy equals to true. So that will also going to do the automatic, it's going to do the deployment for you to Kubernetes as well. Both in the cases of the container image, build and push, and deploying your Kubernetes resources, you should previously be authenticated against your container image registry or your Kubernetes cluster. Now, in the case of SpringBoot, it's pretty much the same thing, except that for this case, the Dekorate team has created a starter that tailors even better the output for SpringBoot applications. So we're going to use that one in case of our to-do SpringBoot application. Okay, let me check again how the Helidon is doing. Oh, there's an IP. Good. So this is my to-do app here, and it's up and running and working. Now let's go to SpringBoot and do the same similar stuff for it, but with a different dependency. Again, going to the pom.xml, go to dependency part, io.decorate. In here, this is the one. I don't know why it auto-generates the Knative ones. And then just take the same dependency in case of it, so in case same version, so that there's no discrepancy. Pretty much when working with Dekorate dependencies, try to keep the same version between all of them. It's better compatibility between all of them, and I think it's going to make your life easier when you try to upgrade between the versions. So going out to the SpringBoot part, there are two ways of interacting with this one: set annotations and, of course, through properties. We're going to use both. Okay, so just me going here and say Kubernetes application and say replicas. I'm going to say 2. I can also say here the service type, which is going to be load balancer, but even more, because I said I can use both. Let's go also to the properties part and say decorate.kubernetes.replicas equals 1, decorate.kubernetes.ingress.expose equals true. And I think it's going to be enough for this case. Just making sure that I'm running on Java 11. I kept all my projects with Java 11, by the way. MVN clean package minus these skip tests, and see what's going to be generated. By the way, I'm using clean package just for you to see that it's going to be everything generated from scratch, and I'm not using any other tricks in behind the scenes. Again, going to target classes, meta-inf, decorate, kubernetes.yaml, and let's check. I have a deployment resource that has replicas set to 1. How decorate worked in this case? Now in my annotation, I said I want 2 replicas, while in properties, I said I want 1. What happens with decorate is that if you define something in properties, that will take higher precedence compared to the annotations. So always keep that in mind. The properties will overwrite the annotation part. So if you're overwriting something in your properties at the pipeline level, then this means that those values will be taken into account. Let's see what was generated more. So there was a SpringBoot to-do app. It also, by the way, auto-detected the fact that I have actuator. So it generated for me some readiness and liveness probe checks. Then the service is load balancer, as specified, and of course an ingress resource. Pretty much done. Now let's go in kubectl, apply minus, actually no, let's do the other one. MVN clean package minus d skip tests minus d decorate.deploy equals true. Just try with the Maven flag. Okay. And you can see here that the resources are being deployed to the Kubernetes cluster. Okay, do not rebuild. Do not rebuild my Docker. kubectl get pods. Okay, so I have my Spring to-do app. Just waiting for it to be running. Come on, be up and running. Okay, it's up and running. kubectl gets services. Maybe this one is going to be a little faster in obtaining an IP. Oh, wow, it was a little faster. So let's go here. And I got my to-do list. Something. Come on. And I can work with my recently deployed app. This was the SpringBoot and the Helidon way of working. Now, in terms of working with Quarkus, there's a slightly difference, because that one works with extensions, so we're going to work with the Quarkus Kubernetes extension and only with properties. So the Quarkus level, going again to pom.xml, and just going here, dependency, and here io.quarkus, and I think it's Quarkus Kubernetes, yeah. Let me sync this one. Cool. Let's start Quarkus, MVN, Quarkus dev, because by the way, Dekorate works at compile time. And let's see what's going to happen. So let's go and tailor this only in application.resources. Okay, so Quarkus started. Let's go in target. Now in Quarkus, Dekorate can be found at the target/Kubernetes, and hopefully reload from disk. Kubernetes.yaml. So I already got something generated, although I know I didn't configure anything. So there's a cluster IP with a config map, with a deployment, and I'm going to explain to you why I get the config map here. Is because I specified it in the Kubernetes.yaml, and Dekorate just simply concatenated that in my generated output. But if I want to tailor this even better, I just go here and say Quarkus.Kubernetes. What do I want? Ingress.expose equals true. Quarkus.Kubernetes I hope that I remember this. Service type load balancer. Then, what else do I need? Do I need something else? Oh, yes. This one is also using a database, I think, and it's using a Postgres one. So I'm going to do Quarkus dot Kubernetes dot env dot secrets. It'll be good to get the secret, kubectl get secret, because that's where I get my password and my user from, so Postgres SQL. And I'm also using the config map, right? So kubernetes.env.config maps. And just looking in this one, its name should be database. So it's going to be database, and it's going to be deployed and all that. Although this looks funny, let's see what's going to be generated, hoping for a good outcome. So let's go here. Services load balancer is great. In my deployment, let's see, I have the environment from the config map reference, from the secret reference. Everything looks quite good. So I just can go here and say kubectl apply -f target kubernetes.yaml, and that's it. So now it creates everything. kubectl get pods. Create conf. Let's see what happened. kubectl logs. kubectl get deployments. Quarkus to do app. That's interesting. Okay, let me see if I got something from knative.yaml. Maybe that was a problem. Okay, so something's going on, it takes a little longer, and kubectl get pods. Okay, it should work. Kubectl get actually logs. Bad request. Where's the bad request with this one? Namespace, blah, blah, blah. Maybe this one? Okay, let me check something. Hub, Docker, Ambra. Docker Hub. Maybe I'm just using the wrong image, which I'm. Let me go here. Quarkus Studio app, tags. Oh, it's actually the right image. Okay, kubectl delete. No, it's 8080, so that's the thing. It's just that saying that's waiting to start, which is weird. No, because it's Kubernetes, and it's the service that is load balancer. It just picks up the first port that's available. The connection to the others is not a problem to it. Okay, that's unexpected. Well, hopefully I'll figure it out down the way. So this is pretty much it with deploying with Kubernetes and all. Hopefully we're going to see how the other parts will go. Now, in terms of working with Knative, what we can do with Dekorate, for example, if you want to use Dekorate with other tools or plugins that are on top of Kubernetes, you can do that. Knative is one example of that. So first of all, what is Knative? Well, Knative is a set of components that can help, you can put on top of Kubernetes, and they can help you in using serverless containers. It has two parts, Knative serving, pretty much used for managing networking, or like traffic patterns, auto-scaling, and revision tracking. So when you're using Knative serving, pretty much you're aiming to have blue-green deployments or canary releases. So it works really great with that. The reason being is because a Knative service, like in the picture here, it manages an entire configuration in Kubernetes. By that configuration, meaning the route to which that you're using to access your application, the revisions of your deployment, so it's aware of the revisions of the deployments that you have done, and also then it collaborates with the deployments, and it can, like, split the traffic across those deployments. That's the power of Knative serving. Now, Knative eventing is there to help you when you want to build event-driven architectures, so you don't deal anymore with the complexities of writing scripts in order to maintain the synchronicity of different messages between your applications. So pretty much, Knative eventing is working with events that are put into a queue, and Knative is taking care of delivering those events to the consuming services, deployed as containers, of course. Now, I'm going to ask you, do you want to see Dekorate working with Helidon or with SpringBoot? So please raise your hand who wants to see it working with SpringBoot. OK, I think I have the majority working with SpringBoot. Jumping in to the, because it's the same that it works with Helidon, so it's no point in like duplicating stuff. Good. Let me just check once again if Quarkus is not working. This is weird. OK. Speaking about this, OK, I do have a Quarkus application, hopefully, deployed somewhere else. kubectl, get pods, and then demo. So I do have a demo one. Yeah. kubectl gets svc minus n demo. OK, Quarkus. So there's a Quarkus one as well, just to let you know that something is working with it. Another something. And that the application is indeed working. By the way, in dev mode, I don't think it has any issues. I'm still started in dev mode with Quarkus, so it should work pretty well. Thread block, I don't like this. Come on. Quarkus Studio app stopped working. Good. OK, let's go to do the SpringBoot demo, and then we'll come back to the Quarkus one. So working with Knative and SpringBoot, and with Dekorate, just add a new dependency. Similar to the previous one, io.dekorate, the artifact Knative annotations, and of course, keeping up the same version across all these. Let me sing this again. And now let's go to the sources. Now, if I got this imported, I can go here and do this at Knative application, and use this annotation in SpringBoot to define my details for my Knative. So for example, I can give it a name. I can also have the revision auto-scaling done with my annotation. So pretty much all of these. But in this case, I don't want to go with the annotation. I just want to go with the properties. So Dekorate.knative. What do I want? The name. K to do app. OK. K to do app SpringBoot, actually, because there are going to be more. What else? Do I need to generate something else? No, I think it's quite enough. Let's just run it as we did before. Clear. yeah, too many commands, so it doesn't remember these for the Spring Boot ones. MVN, clean package, skipping test just for the time. Skipping tests, skip tests, and should be enough to clean out everything. Okay, so now that the artifact was replaced, going again to classes, meta-inf, and I have my knative.yaml generated with my name knative k2do app spring boot. Of course, again, some checks. Everything's working as expected. Simply, I can also go to do kubectl apply as well. Even if it's a Knative resource, I can still work with it like this. Classes, meta-inf, decorate, knative.yaml. So it's pretty much going on like, come on. Come on, internet. Okay, so now we can do this, kn service list, to actually list the services that I've just deployed. And you can see here that I deployed my application, a route has been provided for it, but the revision is waiting for the, you're waiting for the revision to become ready. So this is going to take a little while to be stabilized, and for Kubernetes to provide a stable endpoint to my application. Easy like that. So just Knative annotations dependency, use annotations and configurations to adjust your generated Knative resources and deploy it with either decorate.deploy or using the kubectl or kn CLI. Now in case of Quarkus, if we are to look at it, we don't need to change much. So let me go to the Quarkus app. Quarkus doesn't need for you to add another dependency or something else. It just needs to change the target. So just going on this one. Quarkus.kubernetes.deployment target here. Then I can say knative. I can do knative.name, and of course it's going to be k2do Quarkus, k2do app Quarkus. And of course, I had some external dependencies which would be good to port them to Knative as well. But instead of Kubernetes, I'm just going to use Knative and achieve the same thing. Now, let's see what was done. So let me go to the knative.yaml. And in my knative.yaml that got generated, which I don't like the name, okay. Why is my terminal not listening to me? Come on. That's interesting. If this is going to go like this, I need to remove something. Otherwise, I cannot deploy. So, kubectl delete -f target. Not on this one. Just want to not confuse stuff. Clear. Kubectl delete -f the previous installation from Kubernetes. It was not working anyway, so no big loss there. Okay. But I still need the config map. Okay, that's gone. And let's just do this really quickly because I need the config map to be there. Apply -f src Kubernetes main kubernetes.yaml. Just for the config map creation. And now I'm just going to go and apply my Knative configuration, hoping that this one is going to work better and not have any issues like the other one. Apply -f. So if not present, I don't like you. Might have problems too. We'll see. And also internet, please work. Would be great. Or not. Please. Takes a while. Look. Didn't lose my connection. Okay, it's thinking, doing something, moving along while internet is coming back, hopefully. So, another way to work with Dekorate is by using Helm charts. Now, for Helm charts, you can use Helm annotations dependency that can help you generate Helm charts. Assuming that you still want SpringBoot, right? I'm going to go and demo that one with SpringBoot. So, great, no internet. Going to the SpringBoot part, and out XML, and just not to, come on. Just not to confuse the generation of the Helm resources, I'm going to comment the Dekorate with Knative, and just add only my Helm part. So Dekorate, Helm annotations, and of course, Kubernetes Spring Starter. You must be kidding me. Hoping that internet is going to work at some point. Yeah, it was created. Good. Now let's do the generation of this SpringBoot one for Helm. Need some configurations, of course. Now, in terms of configurations, you can work in two sides. You can work like this at Helm and use the Helm chart annotation in order to give a name, to specify dependencies and other stuff. Or you can also use the properties, which I like to use way more often. So in this case, the decorate.helm properties, I'm just going to rename this to h2do app SpringBoot. Give it a name here, like replace the name of the property name everywhere with the h2do SpringBoot. So let's generate this Helm chart, again with MVN clean package, and see what's going to change. My expectation is that, well, under meta-inf Dekorate, there's going to be a Helm folder with h2do SpringBoot app with the Helm charts, with the service type that has been taken from the previous configurations of Kubernetes, so I don't need to re-implement that all the time. If you're using the Kubernetes configurations, that's being picked up automatically. The path for health checks, the image, and of course templates for deployment, and for environment variables and all the other stuff. So now, just to make sure that I'm not having any conflicts with the installation, kubectl delete, no, yes, delete -f target Kubernetes classes meta-inf Dekorate Kubernetes.yaml. Clear. Why are you working this slow? I should have used my... Slow internet. Google.com. Yeah, it takes forever. Okay, so at some point, we will be able to do a Helm deployment. Okay. So this is eventual consistency, but with Kubernetes. At some point, something is going to happen, and necessarily traffic dependent. OK, clear. Helm install target classes meta-inf decorate Helm h2do app SpringBoot -- generate name. So just generate a name for me for my installation, and it's going to install the same things that were previously done with just Kubernetes resources. Now, if I just want to propagate this across multiple namespaces, it's much easier for me. And at some point, that's going to be started to be installed when internet is going to work again. So pretty much it. This one doesn't have a flag for you to do the automatic Helm installation, unfortunately. You have to use still the Helm CLI. Now, in terms of Quarkus, the Quarkus, you need to add an extension that's called Helm. It's still experimental, by the way. So if I'm going at Quarkus level and say mvn Quarkus add extension -d extensions called Helm. If internet is working, I should get my extension. In my Maven file. OK. So it got my extension, and you can see that Quarkus Helm is 003 and is coming from the Quarkiverse. So it's still experimental, and some stuff need to be defined when working with it. Now, in terms of working with it and defining stuff is pretty much like the other one. So it's still quarkus.helm.name. And in this case, I think it's going to be h2do app Quarkus. What else? Maybe I can also use the property, and I'm just going to go in my SpringBoot one and replace it here, just for the sake of it, because they're pretty much the same properties. Quarkus. OK. Clear. Finally, it died. Mvn Quarkus dev. So I start this again. And of course, the secrets and the config maps are going to be also taken into account in my generated Helm charts. So if I'm looking in target/Helm, the h Quarkus to do. OK. Reload from disk. OK. You can see my values here for the application, for the installation, and everything else being generated as well. So again, the same stuff. The only difference is the prefix that's now Quarkus instead of Dekorate. Now, a bonus track, because we're kind of at the end of the presentation, is working with Tekton. So Dekorate has more extensions or dependencies available, but these are pretty much the most useful one when interacting with Kubernetes. So if you want to create pipelines, or if you want to create tasks or automate your workflows even more, you can start with Tekton by using Dekorate. So Tekton, what it is pretty much the Jenkins that's cloud native to Kubernetes. So if you are looking for something that's more closer to Kubernetes and not using Jenkins anymore, maybe go ahead and try Tekton. Dekorate can help you to generate Tekton pipelines, but in this case only for SpringBoot or Helidon to do apps in this case of these scenarios. The reason being is because in Quarkus is not yet taken into account the idea to have the Tekton for generating these kind of annotations. And for Dekorate to work with Tekton, what you need to do is to add the Tekton annotation dependency and pretty much use the same commands as before to generate your Tekton files. So just to go ahead with it and be done. The last one. OK, dependency. By the way, this is kind of experimental. Sometimes Tekton annotations. I mean, it's still subject to some changes. Kubernetes annotation, please find it. and just comment this one. And again, waiting for internet to get stuff. So at the level of the Java app, you can use this. And insert the Tekton application and have the source claim, persistent volume claim, for example, because you need a place where to have the communication between what's generated by your pipeline tasks in Tekton. So pretty much this. And if you are going to do it again and do the mvn clean package mydisd skip tests, just to check what's going to be generated. In the, compilation failure, yes. There's something that I removed. Yeah. In my target classes, meta-inf, you see here that a lot of YAMLs have been generated. So it has generated the Tekton tasks, the YAML, and how to run that task. It's pretty much giving you on how you can create your own image with Tekton. Also gives you the roles, the security roles, on how you can do that in Kubernetes. You can have a task run, like how to run the specific task with Tekton. And of course, a pipeline that puts all together tasks in order to build your container image and deploy that container image within Kubernetes. So this was pretty much it. This is where you find the code with everything implemented for all the free frameworks and how to run it in for each of those. So that's available for you. And just go ahead and take it. And whatever was not demoed today is available there and working, hopefully. Well, it does work. Last evening it was working. So just give it a try and see how Dekorate works for you. It also works with Java 8 and Java 17. So if you're using the other LTSs, it works with those as well. That was pretty much it. And if you have any questions, I'm looking forward to those. I'll be here around for a few more minutes, so please go ahead and ask me stuff. Thank you. Okay. No questions? Okay, sure. Sorry. So the question was the. There is no impact at the level. I mean, either if it's annotation or a property is implemented, there is no difference in between because Dekorate has the manifest generated at compile time, so there is no difference in terms of that. It's native to how the application is compiling, actually more native to how the framework works when it compiles your code together with it. So it's nothing different. No, it doesn't influence the startup. It just helps to generate stuff. It's not a good question. Thank you. Any other questions? Sure. I am not a developer. I am a developer advocate, so I don't touch productions. So as Dekorate works with so many frameworks, there are testimonials. I mean, this is an open source tool, so we're pretty much, it's not advertised like you would see it otherwise, but I'm sure that you can find testimonials about folks that used it. As you saw earlier, is part of Quarkus. So I imagine that those that are using already the Quarkus Kubernetes extension or the Quarkus Docker or Jib extensions, they're already using it under the hood. So at least in that case. Welcome. Any other questions? Okay. So you still find me here for like 15 minutes, I think. Yeah, thank you for coming to my presentation. Hope you'll enjoy the rest of the conference. More awesome talks are coming over. And of course, awesome EndNote and tomorrow on conference day. See you.